And we're off. Look at that. Microphones are going. We're all hot. The doors are still open, but they're closing soon. Welcome to bring on anyone in. The lineup's out there just dying to get into the room right now. It's a big queue to get in, is there? Probably not. This is one of those little-known services that doesn't get enough glory for what it does. It's a foundation building block. My name is Rick Claus. I'm a senior program manager on the Azure Compute team. And I'm here to talk to you today about the goodness and the awesomeness that is Azure ScaleSets, or VM ScaleSets to be exact. VM ScaleSets is something that is kind of the underpinning for a bunch of other services that are coming up, and it's available for you to leverage right now. And again, the interesting thing, I did a session this morning that's talking about container services, and if you weren't here, go back and check that one online. Some people are nodding. I'm not duplicating my demos, so it's good. Very good. There's a couple of people that are here. So the Azure Container Service is a service that we built that required dynamic auto-scale capabilities for its agents underneath that run all the different containers. It's built on top of a scale set to be able to make that work. So again, you got VMs as the core layer. You then have VMSS above that, and then you got the container service on top of that. So this is the concept of us building you the base infrastructure, building value-add services on top of that, and making them available to you to use and to leverage inside of your environment. And so I'm going to be talking about ScaleSets here. And because there's a couple of hundred of you in the room, don't all jump up at once. I'm curious, though. Put up your hands if you've used VMSS before. 2 people in the room. Out of 2,500 people, 2 people have used them before. Fantastic. So this is supposed to be a 300-level session. This is not being done from a developer perspective, other than from an architecture perspective, because that's my background as an architect and as a consultant. I'm an infrastructure guy looking at how you can piece these different pieces of infrastructure together to turn into a complete solution. And so if you're looking for code, you're in the wrong spot. I even have a Python utility that makes it so I don't even have to make API calls because I'm lazy. I can type really badly. So in this session, we are going to be talking about what the heck is a scale set, why you want to know about them, how you want to use them, and what you can use them for, how you can get started in using them. Then as an infrastructure professional, what do you care about once they're done? How do you monitor them? How do you update them? How do you scale them? How do you auto-scale them? How do you tweak the auto-scale rules to make it all work? But you're really just providing the platform for your devs to go off and to use them, or if you're a dev, or for yourself as well. And then finally, we'll talk about the preview because ScaleSets is continuing to evolve and new things are coming, some of which we debuted last month at Ignite and some more stuff that's coming before the end of calendar year that I'll be able to share with you. And if you stick around to the very end before running off to go off and get beer at the party, you'll actually see for the second time only the largest scale set being able to be deployed on Azure for the second time only in the live world. Yay, isn't it exciting? Fantastic. So I guess we can start off with, why is this guy up here with a funny hat talking to me about scale sets, and why am I in the room? That's what we're going to be talking about. Ideally, think about it from a modern app perspective. I was sitting down talking with my customer earlier today over some coffee. Apparently flat whites are quite nice. It's the second one I've had. I like them. And we were talking about how people evolve and move products to be able to work inside of the cloud environment. So people that have technical debt that exist and have line of business apps run on top of VMs inside their own on-premises environment, how do you get them to start to go off and to use the cloud environment? Well, typically you'll go off and do like a very simple lift and shift. I hate the term, but people use it, where you literally just take the VMs as they are, the different layers of infrastructure, you bring them up and you plop them inside of Azure, inside of AWS, inside of a VM container information, or not container, inside of a resource group, inside of whatever kind of grouping you need, and then you just simply configure it like it is the same as it is on premises. And that's really about it. And you maybe start to leverage a bit more of some more modern technology like load balancers to throw in front of it and stuff like that. Ideally, that's like your V0.1 kind of idea for moving stuff. That's where you're just simply bringing your problems from on-premises and you're moving them up into someone else's data center and you're just leaving them there and there's still problems. Ideally, you want to re-architect the stuff when you can. And so obviously with Azure, you're going to want to do things like, if I have a database backend and I want to make sure that's going to be available when we do a maintenance update inside of Azure, I have to have 2 copies of that database and put them inside of an availability set. That way I'm guaranteed that the machines are going to be across separate update domains for host infrastructure updates, and they're also going to be across separate fault domains. So they're on a different side of the power switch, different side of the storage information infrastructure and stuff like that. That's what availability sets are for. That's not a scale set. but it's simply common sense for what you need to do to architect something to be more cloud aware. So the next level of what you need to do is go and say, this whole thing of the cloud, this Microsoft guy in front of me is talking about how you can just go to the cloud, dynamically turn stuff on, turn stuff off, scale it up, scale it down. It's magical. It is really, truly magical when it's architected to be that way. So you have to think about what layers inside of my application can I go in and actually abstract away from the data, abstract away from the control plane, and just make it so they're doing certain functions, and then I can scale those functions. My application has to be written to withstand that kind of scale. So the easiest way to think about this is you've got some compute nodes that are doing some work. Maybe it's something as simple as rendering web pages or dynamically building content, talking to a back-end database or something like that. Right now, you might have a load balancer talking to a couple of VMs that are doing that. As one example from a compute node. You then want to be able to scale this magical thing across a number of different nodes. As your popularity goes up, people want to go off and buy more stuff. You want to be able to handle more inbound load. They're talking to a separate layer of availability of the SQL databases, let's say, or MySQL database, or whatever it happens to be. That could be running on VMs. That could be running on as a platform as a service solution, like Azure SQL if you wanted to. Doesn't matter. It's separate from the compute nodes. And then you've got maybe some kind of control plane, a management box, or some kind of a background task of stuff that's going on. It doesn't require scale, but still has to be highly available. Out of this architecture, where's my scale set going to be? Any one of the 12 people in the room. What do you think? Right there, the middle guy. He's the one that's going to be the most susceptible to be able to work at the next iteration of how that line of business app is going to work. So during the re-architecture, plan on moving stuff out to make it so that you have this one node that you can go down and break this down. So you're basically having what you call an undifferentiated computer layer, separating them out, or immutable computing resources that are up there inside of that one thing. Think of them as I love to say this, said it this morning, think of these guys. These guys are your cattle. You don't give a crap if something goes wrong with them. You nuke it, and another one deploys. You nuke that one, another one deploys. It's not a gentle snowflake. It's literally cattle that you can slaughter. It's transparent, it's automatic, and it's also a rapid way of being able to gain scale at whatever level you define as load is required to be able to handle that load. It can scale out and also scale back down again. It has to be dead simple to be able to manage this. You don't want to have some complex, convoluted third-party solution to have to figure out the scale and the load and what's going on and the errors and be able to fix it. It's just got to be dead simple and hopefully automated for being able to do it. It has to also be available in a highly available fashion, which means it has to use update domains, fault domains. It has to be aware of the architecture of the region that you're in and all those sort of things as well and operate within those constraints because it is a good cloud tenant that's out there. And then more importantly, I'm an infrastructure guy. It has to be secure. It has to also be able to withstand patches and updates. How do you update 1,000 nodes? You're not using Windows Update, ladies and gentlemen. Like, how do you do this? That's too time-consuming. This has to move like this. You have to kill them off, replace them with a patch system, and then cycle that through all the rest of them. You don't worry about trying to run update on every single one of these things. You don't RDP into the box and hit Windows Update, except yes, install now, or hope that the 3 a.m. thing happened correctly for updates. Of course, I'm picking on Windows right now, but you know what I mean. This isn't Update Tuesday, Patch Tuesday we're talking about. So VM ScaleSets provides you with the ability to scale across a wide variety of machines, but the trick is that those particular machines are absolutely identical as far as resources are concerned. They have to easily be able to be scaled, they have to rapidly be able to scale, and it can be done at scale. We're not talking about tens, we're talking thousands, multiple thousands of these different things. And these are all individual VMs, these are not containers. This gives you more of a level of customization than you would get over top of PaaS. PaaS, you're kind of locked into the solution of PaaS and how it scales and what it works with because we abstract everything else beneath it. You don't have to worry about it. Here, this gives you the level of flexibility to get very customizable for what you want to do. So that's a very big key feature of this, that you can customize this way more than you can customize PaaS type stuff. You have to have availability, obviously, so you have to be able to roll out updates without any kind of service interruption for what you're working with. It has to be low cost. Well, it doesn't have to be. I would like it if you're using D15s for all of these nodes, and you can if you want to. Feel free to Chalk up that credit card. You go up to 1,000 D15s. Right on. But the idea with scale is that you don't necessarily want to have large systems. You want to have commodity cattle, A1s, A2s doing the job, and then scale them out to 100, scale them out to 1,000, and that's how you're going to be able to get your load across them. And also elasticity, the ability to kind of go up and go down as required. So that's the premise of what Azure ScaleSets are able to, or Azure Virtual Machine ScaleSets is going to bring you, and also to be as low cost as possible because it's dynamically increasing and decreasing. Because they're VMs, you're paying by the minute. If it's deallocated, you're not paying for it. So hopefully you're all bought into this. No one's getting up and running from the room, so I'm assuming that we can continue. Good? Awesomeness. Thank you for responding, whoever it was over there. So VM ScaleSets and the Azure Resource Manager. So a VM ScaleSet actually is a resource like a compute resource is inside of an ARM template. It's able to be defined, some parameters, what the machine is, what the base OS is, what the size of the machine is, that sort of stuff. Very simple stuff. What does this mean? This means they're able to be deployed inside of a template. They're able to be checked into source code, and they can be put inside your continuous integration, continuous deployment model of choice that you want to go off and use. This is not something that's proprietary for what we're doing. It's simply a matter of we're using JSON. They're text files. You can edit them with your editor of choice to be able to go off and to work. You have a definition of what the scale set is. They all live on an individual subnet that happens to be created for you. On that thing, you also have a scalable NIC, which is different than a regular NIC because it has to be able to dynamically grow across all the VMs and also shrink across all the VMs as required. These are internal. These are not external that we're talking about right now. You have something like a load balancer in front, which gives you your public IPs. These are internal NICs that we're talking about. You have to have scalable storage. What's the magical limit for how big you can put a number of VMs onto a standard storage account inside of Azure? Anybody? 500 terabytes? How about the number of VMs? 40. They're good. 40 VMs, because that's approximately an OS disk maximum IOPS you're going to hit before you hit the 20,000 IOPS max per standard storage account. So how many storage accounts do you have to have for 375 VMs? Come on, you. Anyway, you, how many? You don't know. So we handle that for you. We do the calculation for you based on this, determine how many IOPS we're doing inside of those different storage accounts. Before we start to max out and performance starts to get hit, we make another one. We put the next VMs inside that other one, and other one, and other one. As you don't need them, we delete them as well. It's part of the automated service. Scalable storage is there. And then finally, extensions. What good are cattle if they're exactly the same? Well, it means I don't have to worry about security patches because I simply update the image and it's now good. I don't have to worry about doing updates to the overall OS because they're all the same and it's all good. It's all fantastic that way. But how do I make it so it's going to work with my app? It's a vanilla image. Extensions is how you do it. Easiest way to do it. Where basically you now go in and add in the magic sauce that goes in and deploys your app on top of that web server as an example. Or your logic code that's going and working inside your system has to get on that machine because it's generic and then gets customized afterwards. So your extensions are the way to do that. Example JSON file, I'm sure you guys want to memorize this. There you go. There's the resource, virtual machine scale sets. And then the parameters for instance count as an example for capacity. Those are probably the two biggest ones. To say, yes, I'm using a scale set, and yes, I've got an instance count that is the maximum number that's inside of my unit of scale that I'm going to be using from an instance counts perspective. There's a number of example templates I'll be showing a little bit later on, but let's actually go ahead and get started, and I'm going to show you this real quick, and then I'm actually going to jump into a demo here. Is more interested in listening to me talk all the time. So how to deploy a scale set. I could do it with the command line, but literally, there's the command. Azure VMSS quick create, done. That's what you do to make a scale set. You answer about 6 questions, and it makes you a scale set. That's the Azure CLI. If it was a PowerShell command, similar PowerShell command, I'll give it to you in just a little bit, to be able to make it, it's that simple. It literally is dirt simple. It's much more impactful if I show you the portal. So switch over here to 7. The light's going on and off for me. Is it? Come on. I know I hit 7. No, I can't even read. I haven't even started to drink yet. That's 8. That's 7. There we go. Maybe I should be drinking. That's what it is. So Look at this. You probably have seen this demo many times. Hit the plus button, that means new. I'll give you a hint. I'm just going to say scale set. There is virtual machine scale set. Comes up in our quick little search. I want to say virtual machine scale set's the one I want to choose. Make sure you read this. Basically, you're able to use a wide variety of operating systems, including Windows, but also Linux distributions, as the base image. You can even load a custom image if you wanted to and use that custom image, but there are limitations with that. They're only resource manager. These are not classic resources we're making because they're ARM templates. Go ahead and make a virtual machine scale set name. So let's call this one here Ignite NZ. Keep it simple. I'm going to make this a Windows box. You cannot use the name admin. It's a restricted name. And if you're doing this inside the portal, it has to be 12 characters long, in case you didn't know. And they have to match. Demo, put this in here, NZ VMSS Demo 2, just in case I have another one. I'm going to do inside of Australia East. There's the first thing I should warn you about. I'm going to make a dynamically scalable resource of VMs and cores. There's a limit on cores per region. Make sure you file a support ticket to get your cores increased. Otherwise, your VMSS will stop at 20 cores because the default limit is 20 VMs inside of one region. So if you're looking to make a VMSS that happens to have 150, not going to work. It'll fail after 20 start, and then it won't work anymore. Coming up here, give me a domain label, please. Okay, well, let's call this guy Ignite NZ D2. Operating system is 2012 R2 data center. I'm going to make this an instance count of 10. And I'm going to make it a standard D1 V2. So it's the newer age of hardware. So SSD-based machines, Intel-based core processors, and about, I want to say, 3/4 of a gig of RAM on that box. Nice and simple. And I'm going to say OK. Oh, no, I'll say enabled for auto scale. Quick little thing right here. I'm going to come back to this, but auto scale basically is the ability to go through and define rules. So the minimum number of VMs that runs, it's never going to shrink below 1. What happens if I go to 0? I no longer have any compute that's going to be hit by that load balancer, and it's going to give me error messages. So you have to have at least 1. Then I'm going to say what's the maximum number it's going to go up to is 10. Scale out when you hit a threshold. The default rules to make it dirt simple is using CPU. So basically, when my overall load across my different instances hits 75, then go and increment it another one, because I'll drop it below 75. And then it raises up to 75, and another one kicks off. And then another one kicks off, and another one kicks off, and does that as far as the growth is concerned. It's going to increase by 1. I could be absolutely crazy and throw caution to the wind and say increase by 10 instantly if I wanted to, and max it out. The scaling algorithm takes increments, and it's an average over 5 minutes for all the nodes. Scaling down, it scales down slower, but there's a separate rule I control for that. You can have different levels. Generally, you want to have it scale fast and then slowly come down so that in case another burst happens to come. So in this case, I say scale down 25%, number that goes to decrease, and it is decreased by 1. Oh, I didn't know I could zoom in with that. That is cool. That's a new thing I didn't know for zoom in. So I'm going to disable that for now, come back to the scaling, so I can just go ahead and get this guy started. It does its checks to see if the DNS name is already in use. That's for the load balancer that we build for you. You have to pass validation, and then just be aware, I've now just authorized with this OK button and with this purchase button, because I'm going to read this purchasing agreement, that I'm going to be liably responsible for up to 10 cores of D1 V2s inside of my amount. I only get billed for when they actually get built, provisioned, and run. But if they get deallocated, I don't get billed for them, just like I would a regular VM. That's all that little legal gobbledygook is talking about. So I'm not going to wait here for this entire scale stuff to be built, because that would just be stupid. It does take some time to build the infrastructure out, probably about 10, 15 minutes for the very first time. But then it starts working and writing. I did not do any customization of that particular environment to say, here's the extension I want to use. Here's the stuff you need to do after the fact. Let's go and talk about that part coming up next. I know it's 5, and I hit the right one. Because I, pardon me? Okay, correct. So I aborted the auto scaling. The question was, did I now just deploy 10 instances? The answer is no. I actually deployed 1 instance because that's the minimum. And until I give it a rule or I manually choose to raise it up, I can go up to 10 with this particular set. So the more efficient way that you're really going to be doing this, once you've kind of tinkered around with it and figured out how this works, is you're going to be building a template. And you're probably going to be using a template for your starting point to be able to go and create these, because they have some example templates that then go off and call a chef extension or call a custom script extension to go off and do additional configuration, or does a DSC extension to go off and do some stuff to these individual boxes. So that's generally where you're going to do it. Now, here's where it gets kind of cool is on the development side, if you're a developer, you could actually make API calls to the REST API to do all this stuff. So it could determine on its own when it needs to go off and scale and do something, and simply go off and make that call, and it's just going to go off and build it up and make it bigger if you need to, or take it down again. So the REST and the SDK and the REST calls are available to go off and to work. And then finally, in the context of that application for what's going on inside of that thing, you need to now figure out how to get that deployed. And really, there's about 6 different ways that you can go off and deploy stuff. So the very first way for using ScaleSets is actually the easiest way, which is to use a pre-built template that's been made by one of our partners that leverages ScaleSets underneath the covers to make these things work. So the one I showed off this morning was obviously Azure Container Service. That uses a VMSS underneath the covers to be able to handle the agents and the management nodes to make sure that they're maintained, they're updated, and they're ready to go and can scale as required. There's other ones, like for instance, the batch service for doing batch jobs and data processing for Microsoft. They also have one as well. But then you've also got some stuff like a Brocade load balancer. You've got some Service Fabric stuff. You've got DCOS on Mesosphere, which is separate from ACS, but can use ACS if you wanted to, are some examples of what happens to be there. So an example for DCOS on Azure, this is actually a custom-built version of DCOS on Azure that's maintained by our partner, Mesosphere, that they then go and they charge you a licensing fee to be able to go off and to use, but they give you the value add of being able to maintain it and to work with it. So that's a very cool one as an example of what's possible. That's way number 1. There's more that are in there. If you're an ISV that's making an offering available on top of Azure, you could also publish inside of our marketplace and use VMSS if you wanted to inside of your environment. The next most common way to do it, once you've now started to work with your development teams and you've decided that, yes, you do want to do stuff with ScaleSets, is you're probably going to be using extensions. The idea is that you're able to go off and define inside the template a custom extension that's going to be running. Maybe it's going to be a custom script for Linux. Maybe it's going to be a DCOS configuration on the Microsoft side. Basically, you go off and you define your initial scale, your initial rules, but then once the core blank OS has been deployed, a level of automation kicks in to customize that one VM to get that guy up to work. Then you simply roll out the extension and updates like an OS update. So you can start this off as it is right now. You can go in and change what we call the model of your VMSS scale set, and then you're able to say redeploy that, and it simply refreshes the machines with the extension now on top of it. Every single machine is identical to every single other machine. That's what's critical to understand here. If I go in and do something unique to one of those boxes, it's no longer a functional scale set. I've just broken it because I now have 99 machines and one of them's got a problem. That's the one you use when it's modified. I think that's a song, isn't it? Did I hit that? I tried. Trying to be cool. Next up, number 3, custom data and unattend files. So the custom extension assumes that you're going to be having networking connectivity between these boxes to go off and talk to another external location for where that blob happens to be, where that custom script happens to be. Sometimes you don't have that ability, in which case you have to go off and do the good old-fashioned unattend files on top of Windows boxes, or some kind of a custom local script on a Linux box or something like that. They can go off and talk to a share that's inside of your VMSS network or subnet if you wanted to for your architecture, and they can go off and copy down files and do some stuff unique to that type of environment. So there's no dependency on an external network. That one there is possible. Simply a matter of referring to a custom data string inside of my JSON file when I do my deploy and my model as one option. Another example that you can go off and do, number 4, is probably in my opinion, the easier way to do this, which is known as doing some level of configuration management. This is where you would use your existing technologies for how you manage your systems, and you simply call on it. So this could be a DSC configuration that's being applied. Your machine boots up, talks to your main DSC server, or in this case, Azure Automation DSC, which is now built into Azure, and knows that, oh, this guy's talking to me, and he's supposed to have the following .NET configurations, the following IS configurations, go do, make it so. As I like to say for DSC, you have that work. If you have Linux, that's not going to work potentially. Well, actually, I think they kind of do now. They have PowerShell for Linux, but that's another discussion eventually down the road. The main thing is that if you want to configure Linux boxes, you could be talking to an Ansible tower and have Ansible scripts running. You could be talking to a Chef configuration that then goes and talks to a Chef configuration server to get the recipes and then goes off and applies them down in that box. You could be talking to a Puppet environment and have a Puppet script come down and configure that local box. That's all possible and much more scalable when you're talking about hundreds of machines or thousands of machines inside of your environment. So configuration management, definitely a way to do it. Some kind of host maintains your consistency, and then the add-on, the extension, is the one that goes off and talks to it. It's going to come up, it's going to be configured, it's going to require a reboot, and then come back up again and ready to go, generally speaking. Number 5, kind of going to the next level and using this from a container perspective, from a containerization perspective. You obviously can have your app on top of a container, have this as part of an engine that you're going to be using, and you have to build that infrastructure to go off and work. We use Azure Container Service as our example for how this works and baked in for you. But basically, the scale set is always going to be stable. It's always going to be available as far as infrastructure is concerned. The app containers are managed independent of how this all runs. They simply run on top of the engines of those individual scale set and machines that are there. Number 6 is another option, which is a custom image. Custom image is possible, where basically it goes off and comes up as vanilla, but then knows it has to go and talk to a particular environment. So in which case you've got, in this case, a developer is going to go and check into code into some kind of GitHub repo, like, as an example. It's going to go off and have a monitoring service like Jenkins is going to watch that, notice there's been a change to that code and checked into the master branch. It then is going to go in and take all the code that's changed, build a new package, build a brand new deployment mechanism, and that's going to go in and basically update the model, the JSON file. It says new thing is there. It then is going to go and blow away the image and then bring a new one back and have that new code built into it. An example of this is an open source or a technology that Netflix actually made, which is called Spinnaker, which allows you to have the concept of a immutable VM that exists. When they go off and deploy, they don't even bother trying to update the VMs. They just simply replace the VM, kill it, and bring the new one up with the new code inside of it, the new patches inside of it, and it just goes and scales across that way. For the way that works. We actually have an example of using Spinnaker on top of Azure by this gentleman here called Larry Guger, who's gone and made it available, set it up using the same open source tools, and has it up and working on top of VM ScaleSets as one way of trying to do it. Very, very cool. Jenkins is the one that does the monitoring and then kicks off the Packer process, which then goes off and makes that new image available and deploys it. If you're not so much into the open source tools on the Linux side, you want to stay on the Windows side, we also have our dev test labs, where Visual Studio Team Services is now monitoring what's going on. You go in and you make a new package. You use what's known as a bakery for the place where that particular image is stored. That gets updated, and then the engine goes through and deploys this through Visual Studio on the release branch, stages stuff inside of test, inside of staging, inside of production, by, again, simply deploying the VHD. In case you haven't noticed, these are big chunks. They're not specialized. They're not tiny little tweaks that happen to the system. You just nuke the cattle, replace it with a new calf, and have it grow up and continue to work for you. And when it's done, you kill it and you bring the next one in. It's kind of gross, but that's what it does. The whole concept of disposable servers that are out there. So that's your 6 different ways you can go off and do a deploy on the system. In case you're interested, here's your cheat sheet for when you should be using which type of deployment model for different options. And it's pretty cool for being able to do it. My personal preference that I've seen and a lot of people go off and use is more the configuration manager from an IT pro infrastructure perspective, because they're used to using those tools already and they simply leverage them up inside of the environment. You can build your entire environment, the recipes and how they all work if you're talking Chef, on-premises with your on-premises server, take those recipes and put them up into an enterprise image up inside of your subscription. And you even have an enterprise chef implementation available inside a marketplace you can deploy inside of your environment. So very good for being able to reuse your code, for being able to manage that. It does take a bit of time. So that's the architecture of how VMSS works. That's the way you get your code to run on top of VMSS. Yes, sir? What happens if something fails when it tries to create your machine? It kills the machine and creates another one, and kills the machine and creates another one until it goes. And it's logging every single time it tries to do something. So in case you end up in a situation where you don't have enough quotas and cores, it'll actually error out and tell you that something's gone wrong. And you'll just see all this continued activity inside of your account. But because you listen to this super fantastic session, you know to increase your quota before you try to use ScaleSets, right? I actually, it's funny, even I have to ask for quota increases. And so for my demos, I actually had to ask for 100 cores inside of Australia East. And it was denied. And I'm like, what? I'm doing some demos. This isn't like a permanent thing. And like, oh, okay. It was denied because I don't live in Australia. And there's no good reason that I put inside my request for the service request other than for a demo. I need 100 cores. It's like denied. So I jumped on my internal mail chat and I found the support engineer and I emailed him. I was like, come on, man, what's going on? It's like, oh, okay, let me see what I can do. And then 4 days later, I got my core increase. So just in time for the demo, which is perfect. So correct, yes, the borders that exist for where you're allowed to deploy the cores being inside of Australia with the billing address of Australia definitely has changed. But I think there's probably still some legacy stopgaps for these crazy guys that work at Corp inside the engineering team that don't get to have them back again. You have to ask for them nicely. So that's what my guess is. Or I guess I got to buy the guy some beer sometime to make it so he just lets me have it on the side. So this is being recorded, right? Oh, wait, it is. VMSS, here's an example. So where does this come into play? I gave you the theoretical example, right? Of like, you got a web app and here's what it does, and sort of stuff. Let's actually look at a real actual application that does this from an architectural perspective, what this is. So you guys know what an MRI is, an MRI machine. MRI basically takes these very detailed high-res pictures, but you have to be completely still inside of this weird machine with magnets and stuff like that for what's going on. It's a tunnel that you're going through, like look to the light. Picture the fact that you've now got, gigabytes of data coming out of this machine for these little slices of pictures that they're taking, and you're trying to take a picture of someone who has a respiratory issue, and it needs to be live pictures of the lungs breathing or of the heart with the valves moving and stuff like that. That's a huge, massive amount of computational information that has to be able to be processed on the fly to render these live images. So you can't ask someone to have their heart stop beating while we take a couple of pictures. This has to be happening live. And so there is a open source application that's been created. It's called Gadgetron. That proves this out and how this works. But basically, you've got an MRI machine, you've got an MRI host that's accepting this kind of data and this kind of information. It goes off and basically will take that information of the MRIs, drop it up inside of what's known as a relay node inside of Azure as one example, which is data that needs to be processed. And then you have a VMSS that's looking at that of 8 machines. That's our scale unit, is 8 machines, 8 high-end F16s. F16s is the highest number of cores, lowest number of memory density machines you can get on Azure to do computational stuff. Those 8 machines are set up to be able to go and to analyze those pictures, render them, and then drop them back down again to the MRI host. Now, when the load starts to get too big and the pictures start coming in too fast, VMSS kicks in, and in about 3 minutes deploys another 8 cores, another 8 F16s, and will continue to deploy more until it goes back down to a normal level, as it's processing all this data and all this batch information as it goes. And it does it in a 3-minute increment for being able to do all this kind of configuration. So obviously these images are customized. They've got the application that does the rendering built into them. They know where to look and they're all set to go. And then as they're no longer required, because the hospital doesn't want to be paying for 32 F16s, that actually sounds kind of cool, F16s. I never even caught that before. It scales them back down again, so I don't have to pay them. It doesn't scale them down immediately with the engine rules that they have in this particular project. They scale them down gradually, just in case more pictures come in. And then if there's nothing left in the queue, they get rid of them. They don't even need them anymore. So that's one real-world example. You can actually go and download at Azure templates from another guy that's gone ahead and created this for proof of concept for the healthcare industry that they can go off and deploy. So prior to this, the individual hospitals and the MRI processing labs and stuff like that used to have massive amounts of compute power on premises next to those MRIs to be able to do this all locally. And they had to do the capital expense for that. Now that's gone. It's now up inside the cloud environment, networking connectivity. It's all secure. It's inside of secure blob storage. Goes up, goes down, comes down, gets processed, and all set to go. So real absolute thing that exists. You can take a look at it if you want to. The current demonstration for how this works, proof of concept, goes up to 32 nodes. There's no reason why I can't go larger. But I can go up to 32 nodes. But obviously a timer goes and sets them down. So as an infrastructure person, one of the first things I want to know is, okay, this sounds cool. I'm bought in. I can get my devs to basically modify their applications so that they're able to go in and make it so they've separated out the uniqueness of the individual machines. They've added in the level of automation that is required to be able to make it so they've got the compute power they need to be able to do the work they're supposed to do. And they've separated that out from the databases. They've separated it out from the other different components. We know exactly where my layer of scale happens to be. And now I can use a scale set to define that. How do I monitor it? How do I know about it for what's going on? Well, how about, instead of showing you a screenshot of the portal, I'll press the correct button and I'll show you the portal to be able to see what it looks like. So I have, in case you don't know, again, I love this. This came out a little while ago. The fact you can go in, I have a lot of different things I do inside of Azure. As I switch hats, get that? I switch hats to my VMSS discussion as opposed to my containers discussion. I've got a different desktop that I'm looking at on my portal that's in there. So this is my VMSS demo. You can see here that I've got my, this is my new Ignite NZ VMSS scale set that I made earlier based on Windows Server. It is up and ready to go. If I want to go in and take a look at this guy, if I take a look here, this is my actual resource, which is virtual machine scale sets. This is the icon for what it looks like right there. If I take a look a little bit further, this is the load balancer that was created already, the public IP, the load balancer, the virtual network that this guy, currently one machine out of possible 10 is there. And then I've got a whole bunch of storage accounts. So because I said there are going to be 10 machines, it provisioned extra storage accounts because you don't pay for those unless there's actually data inside of them, right? So pre-provisions them, ready to go. Who cares what they're called? They're expendable, right? I just need to make sure they're unique and ready to go. Plus, I can never remember if I'm allowed to have uppercase or lowercase and numbers and stuff like that anyway. So they're available. I choose the scale set over here. I can take a look at it. And you can see that I've got a super busy scale set. Oh, look at that. I went all the way up to 4% use for some reason on this guy. And if I take a look down below, I have all those different machines up and running. So in actual fact, I don't remember if I typed in 1 or if I typed in 10. I think I reversed my numbers that I put into my field, and I actually got all 10 machines deployed. I meant to only have 1 machine deployed. So let's actually go and fix that. I can easily go in here because these guys are individual machines for instances. Choose instances, and I can say, I don't need all these guys. I'm going to get rid of these ones and simply go in and delete them. Gone. They're cattle. I don't care. They're dead. They're just useless to me. So go ahead and refresh this guy just to make sure it's refreshing correctly. It's always risky. Come on. Difference between deletion versus deallocation. If I was actually going to do a demo that had some kind of a load I could have placed on them, a deallocate, they could just restart back up again. Very quick to reprovision again. I deleted them because I just wanted to get rid of them to show you how easy and expendable they were. And look at this, because I hit the refresh button, now I've got this delay. Oh no, here it comes. It's coming back. Instances, and you can actually see here that I've got some of my machines going through a deletion. If I can move it over, there we go. So I've got my node number 1, 2, 4, 6, 8, and 9 are actually going through a deletion process. It'll go. So the question is, what would happen if I deleted all the machines and one of them is doing a transaction? The transaction potentially would be lost unless my app has enough logic to know how it's going to be looking at that transaction. Correct. So you have to build this logic into how you're going to be running with your apps. You wouldn't be doing any actual data work on this device. You'd be looking at a queue somewhere that would go off and act on that queue, and then there have to be some kind of a mechanism that says, I'm done doing that particular piece of work, and then delete it. And in which case, it wouldn't delete it until it was done. It's still inside the queue. The next guy could pick it up again. And again, it's a mind shift for how you have to architect your solutions to understand how you can leverage these things inside of VMSS. And look at that. As I was talking, I'm now down to much more manageable 1, 2, 3, 4 different systems that are inside my scale set. Now, even more interesting than that, so the question is the load balancer now automatically updated because there's now no longer 10 destinations, there's now 4 destinations? The answer is yes. Part of the operations of management for how this thing works is it goes in and updates the load balancer. It knows there's less. It doesn't bother trying to do it. Does the app care? No. The app's talking to that load balancer. It doesn't know how many's on the other side of it. It just simply knows I talk to this guy and the work gets done. That's the logic behind how the scale happens to work. The connection to the load balancer is stateless or stateful? What, for coming in or for the load balancer down in the box? It's stateless. It just simply knows it has to talk to this one guy and it's done. Pardon me? That'll have to come back to you too. I've never been asked that question before. Stateful? Hang on. Okay, so my bad. Inbound, stateless. Inbound to the individual machine, stateful. So people know what it is. I need a drink. That's what it is. Let me show you this Resource Explorer. I've been showing you the stuff inside the machine for the configuration. Basically what I'm doing is I've just changed the model. I've gone in and deleted a bunch of machines. I've reduced the capacity from 10 down to 4. So I've changed the capacity of that particular scale set. There are no auto-scaling rules that would scale this guy up or scale this guy down. It's going to stay at 4 at this point in time. So I'm using this thing called Azure Resource Explorer to be able to look at my live subscription as it runs. And I wanted to show you that just that one little tiny reference to where it is. So there's my RIC demo. There's my resource groups that I'm talking about. This is the Ignite NZ demo. Or no. See, now I think it's this guy right here, Ignite NZ Demo 2. This is the guy. Yes, I got the right guy. Phew. So you can see here, my definition is I'm using a standard D1 V2 box when I created this. I have a standard storage being used, and I currently have it as a capacity of 4. If I actually went in here and wanted to change this, where is it? Come on. Wake up. I'm in read-write mode. I am connected to this. My edit button is not waking up. It's in a pause state. We'll come back to that guy there. Basically, I should be able to go in, change my capacity from 4 to 10, hit put, which basically does a update to the model. The VMSS service notices that the model has been updated and says, oh, it's going from a 4 up to a 10. I need to go in and provision more machines. It goes in and provisions the exact same identical machines, exact same automation at the end when they're done deploying to be able to go off and to get this guy going. But I actually have a running VMSS that actually has some workload associated with it. That's just my generic blank one that I have there. It's called the bottle demo. So what I want to show you from a monitoring perspective is I wanted to show you this guy is set up that was basically running as a 10-node scale set. that has a Python script doing some work that generates load on the individual boxes. As the load is up and running on that particular box, if the load across all the boxes gets up to 60%, then it's going to go in and kick off another node. And then the CPU load goes below 60% until it goes back up again, and it kicks off another one, kicks off another one. So you can see here I currently have 2 images running, this particular little utility for where it is. If I take a look at my instances, I've got 2 of them that happen to be there. If I take a look at my activity log is going to show me all the different types of activities related to ScaleSets that have happened in the last hour in this case, what I'm looking at. And you can see here that when I made this, if I bring this guy up so you can see it, come on, get the right progress bar here. Scroll down to the bottom, scroll with small resolutions. Basically, this was the creation of the scale set. This was the completion of the scale set being done, but then it had a scale down request because there wasn't enough workload going on, and it was going from a scale down from 4 instances down to 3 instances. Another scale down activity occurred 5 minutes later because the interval for auto scale works at 5-minute increments, and it went from 3 down to 2. And then if I take a look at it now, it's stuck at 2, and it basically now says it's complete and sitting at 2, waiting to go off and to do what it needs to. Simply saying it's nice and healthy for where it is. These logs are aggregated and pulled from all the different instances that are inside my scale set to one spot. I can filter and run and do some stuff like that on this individual box if I need to from a monitoring perspective. Obviously, you can also go in here on a monitoring perspective, and it's on the overview tab, like anything else. I can go in and edit the particular chart that I'm looking at for CPU. I can add in different options and different types, and I can also go in and put in alerts on that as well to basically say, send me an email to do something when something goes on, if you wanted to have it manually done. Go back to here. There we go. Good. So, some ideas on monitoring that are built into the platform for how to be able to go off and to work with that guy. If I flip back over here to my slides, there's the individual cores for the scale sets and how they are. There's an example of what it looks like, the editing of the chart to show you some more, and the ability to go through and set up individual alerts as well on that individual system. And there's some of the logs that I showed you there as well. Now, monitoring is one thing, but what about doing ongoing maintenance? What do we do for ongoing maintenance with these different systems? I have to go off and do updates and patches. It's going to take too long to go in and do some kind of a patching routine on these individual boxes. It's much easier to simply go in and do a refresh on them and be done and happy with them. And so that is possible to happen as well. I have there we go, connect it back up again. So there's a utility that's available. I'll give you the link to this one here. This is actually a little Python tool that the program manager for VM ScaleSets created. His name's Guy Bowerman. And it basically does API calls or RESTful calls to the different systems to be able to do some stuff. You can actually see here, this is a 100 scale set that exists right now inside central US. Currently is stable. And it has a nice graphical depiction because that was one of the questions I had during the containers discussion is, how do I ensure that my scale sets are designed in such a way that they adhere to the best practices of spreading the load across fault domains and spreading the load across update domains? And so this actually visually represents, in querying the APIs inside of Azure, where each machine happens to sit inside of which update domain, inside of which fault domain, for what's there. Now, I want to go and update this guy because I'm running CoreOS. And I happen to know that there's a new version of CoreOS image available that's going from a 15 to a 17. And I want to go off and update this. Well, all I do is I simply update the number reference to it, say update the model. And then it's now waiting for the bottom here, response 200, that says it's actually gone and updated the model. So what that has done is gone and modified the JSON file that's being used by Azure ScaleSets to say it's all done. There's the succeeded I was waiting for to say it was actually committed and finished and now up and live. But now all of my machines are out of sync for what's supposed to be inside that model. There is the option to go ahead and do an automatic rolling upgrade, but that's off by default. You generally want to have more control over when you want to do this upgrade. So what I'm going to do is I'm going to hit the proper query to say, let's go ahead and update 10 machines at once and do a rolling upgrade. It's now submitted the request into VMSS to be able to go off and do that upgrade. And then you're going to start to notice that 10 machines at once across update domains and across fault domains are now going to be updated across. And it's doing its very first batch. And there's the first 10 machines that are now in an offline state. My load balancer doesn't care. It simply is still continuing to receive inbound and talking to the remaining boxes that are out there that are all still up and working and great. And then when these guys are done being re-provisioned again, because they're just VMs, they get deallocated, new ones get allocated, and then the automation from the extensions kick in to finish the configuration. When these guys are done, they come back up, they'll show up inside of a green state, and then it'll move and wait till they're verified, and then we'll move on to the next batch of 10. So these happen to all being done across five different update domains inside of this one fault domain, and then go across and across and across inside a type of environment. You have access to download this tool yourself if you want to and set it up. It's relatively easy. It's available in open source, and it's being contributed and updated to on the fly. Yes, sir, very patient. Mm-hmm. Yep, so if I can distill the question down, if my work coming in from that load balancer is going to be different with these new machines that are coming in because the code is different, how do I handle the rest of the machines until they get updated with traffic coming in? That's going to, again, have to be part of the logic of your current application. If you're talking about this without using VMSS and you're talking about an application layer PaaS, like app services, they actually have the ability to have staging and production and do the switch and then put so much traffic to one and so much traffic to the other one. This doesn't do that. This gives you the infrastructure to facilitate that if you build that level of application logic inside of the way your application's talking to this. So you have to build that part. We've given you the update engine to be able to do this. This is different than if you went into each machine and actually remoted in, did an update, and then went, and then did the same thing again someplace else, and same thing again someplace else, to be able to go and to have that up and going. So this is going to take probably about 10 to 15 minutes to march its way across the different systems as it goes, but it will eventually achieve a level of consistency with everybody at 899.17.0 across the board. I'm going to grab a drink. One moment. Is there a reason why I'm not updating across fault domains and update domains? Just the way the logic was written for this particular autoscale. That's it. You're assuming that I'm not doing all machines inside that one fault domain, as you can see, and that also I'm spreading them across the update domains. So I chose the number 10 kind of arbitrarily, but also because it looks nice, and my OCD is happy that I'm doing 2 lines at a time before it goes to the next one. An interesting thing, in case you're wondering as well, is the fact that it simply increments the number of the VM for the VM name. Starts off with 1 or 0 and goes 1, 2, 3, 4, 5. So as these new machines come up, they don't reuse the same machine name. They actually now have a new name coming in and registering with the different systems. And you'll see this go and cycle through and continue on. A little slow today. I was expecting at least to go through a couple here before this was going. But basically, when I updated that model, I literally just changed the reference to the OS version, and then it's now using a different OS image on my box. This guy will come green eventually, and then move on to the next one as we go. Yes? Pardon me? The question is, can I do a more capable load balancer inside the system? We give you the one by stock out of Azure for where it works. I've never actually thought about swapping it out just because of the logic for how it's going on. I'm going to get back to you on that one there because I don't actually know if you could swap it out. You can put whatever you want in front of that, obviously. But there's, by default, VMSS is using the built-in load balancer from Azure as part of the way the JSON file was built. You could, in theory, swap some stuff out with a different resource provider at the load balancer level. Finally, we have our first 10 machines done. They're coming back as green. And then this guy is going to kick in and say, OK, they're all green. They're live. They're responding to my healthiness now. I'm now going to go in to update batch number 2. And you'll see the next 2 stripes of machines go off and start and be able to work as well. So pretty cool stuff to be able to go off and update on the fly, to be able to go. In theory, I could also, not whilst doing this update routine, but I could have also scaled down or scaled up using this little tool here as well, too, by simply changing the capacity up above. But I decided to go with just the Core OS version that happens to be there. So I'm hoping I'll just see the next little section come and turn off, come back up again. Almost. Trust me, it'll work. It'll be there. Let me show you the graphic while I'm waiting here. I'll switch back. I'm losing my clicker. There it is. So how do you update a scale set? As I just showed you, you have the ability to go through and do application updates. All you do is update in the model to change the script that gets run or to change the configuration. I can now tell you successfully the next 2 batches of Christmas lights are now yellow, so it is progressing successfully. The ability to go through and do an in-guest update as well is possible with some kind of extension or a patching update that goes through. Then also VM image updates as well for just simply updating the model, swap out the machine image, and then off you go. You also can go through if you needed to, and you can even update the image reference model to replace the VM with a larger size VM if you wanted to. But generally, you're going to be going in and possibly doing updates to the OS or updates to the application automation that takes place after the fact. So I could have gone in and changed from a D1 to a D4 if I wanted to on this individual size. And then that also applies to every single other machine as well as it rotates through. So not only can you scale wide, you can scale wide and up too if you needed to, and then back down again. You can also increase the number of capacities too. So from a scale perspective, I already showed you this with the resource manager as one example for how you can go off and edit this. The capacity can be changed from a number from 1 to 10 to 100 to whatever you need to. The capacity is the property of the scale set as there, but then it needs to be redeployed or refreshed, if you will. That's out there. The new VMs are spread across the update domains and the fault domains automatically and storage accounts. The ID increases by 1. Eventually, when you hit a couple of million and the machine name gets too long, we start back over again. But when you delete them, it deletes the highest numbers first and then goes back down to the numbers. Scaling with PowerShell can be done, and scaling with the CLI can be done as well, as opposed to editing the actual model by changing the capacity. So I could go through and choose the Azure VMSS scale, the resource group name, the name of the scale set, and then a capital C is capacity. It's set for 10. I could have put it to 20. I could have put it to 100 if I wanted to. The ability is basically any tool that can edit that model, like a Resource Explorer can be used as well. Yes, portal ability will be there. It's not there right now, but it will be available in the next little while for being able to simply tweak something inside the portal. Right now in the instances view, you can only delete and deallocate. You can't go and increase the capacity that's there. Now that auto scale that I showed you earlier is something that is relatively new that came out for how this guy works for auto scale. Why do you care about auto scale? Well, the idea is that you have a CPU increase or app increase for your environment. You've got this initial spike that goes up, and then maybe you're going to have a little bit of a lull, and then all of a sudden you're going to get this other kind of spike that can go up as well for 3 specific cases why you care. The first one is simply, hey, will my app keep on running? Can it handle the load without throwing errors? That's generally the first reason why you want to understand if autoscale is working for yourself or not. So app resiliency to keep things up and running. But after you've survived that initial load of oncoming traffic and you need to be able to fix it, well, generally you don't want to run with machines you don't need. The whole glory of the cloud is that you reduce the number of instances and then you save money because you're not being charged for them. So the reduced cost where you don't need them is where you want to auto-scale back down again. And then finally, if for some reason something goes haywire and you got a massive spike, that's not simply a matter of having your app resiliency being affected. Maybe something's going on. Some of your images have been compromised or something like that. You're going to want to know about that too. So basically notifications can come into play with an auto scale as well. So when things go bad, you want to know what's going on. Through the portal, it didn't exist as little as a month ago, that little green or blue box from disabled to enabled is what I showed you during the creation process, allows you to choose how to do auto scale very, very quickly. And this puts in default rules. Once they're in there, you can now take a look at the proper entries that you can edit inside of the Resource Manager template or through resources.azure.com to be able to go off and to take a look at full control of this. And then also through the CLI and also through PowerShell to be able to go off and auto scale, and possibly even through the agent as well. If I took a quick look over here, back on this guy, and I'm going to show you this just really quickly here through the Resource Explorer. That's my time. On the Resource Explorer side of things, the bottle demo has an auto scale rule. It's done under what's known as Microsoft Insights. And you auto scale settings. And the auto scale settings basically define, here's my smallest to my maximum large, default increase of 1. When a processor time happens to hit a certain threshold, being 60, go ahead and increase the count of 1. And then I have a second rule that kicks in, also on processor time, that says when the average is less than 30, go ahead and decrease by 1. Very simplistic rules. They can get very, very complex if you want to. But they're stored inside the model, which is based inside of JSON, to be able to go in and to control how your auto scale works. Quick part here for the architecture for this particular thing working. Right now, what we have is there are Windows diagnostic agents inside of your VMs. There are Linux diagnostic agents inside of your VMs that are pushing this performance data inside of a metrics database. That metrics database is going in and being looked at by the monitoring service, otherwise known as Insights, and it stores for long-term storage inside of Insight storage. It then goes in, and when the rules are an exception, it then goes in and does the auto-scale service background job to be able to go off and provision more VMs or deprovision VMs. This is the current model for how this works. It's being changed to make it so that it is no longer going to be doing this. If I just take a look at this last little bit of a slide to wrap this guy up for you, for auto-scale. In the auto-scale world, what's coming in the near future is that out of the box, auto-scale is going to come and no longer require these agents to be involved. It's now going to be natively talking to the host to get the information about the VMs. It's no longer going to be relying on the agents. This is good because people don't like having agents inside their VMs because it's a foreign little chunk of code that we manage. And so this works for both Windows and for Linux. You also don't need to configure those agents. You don't need to configure any data. And you don't need to configure any storage accounts for them as well. So definitely very cool. Also handles it in case the VM is under duress and extreme load. It may miss being able to log data inside of those different agents as well. Now that's no longer a problem. So that's coming in very, very soon in the next release of what's coming on with this. And finally, even faster, more reliable metrics. I was showing you stuff with 5-minute increments. You're going down to a much smaller level of increment because there's no longer an agent having to dump stuff inside of a database. It's going to be going down to 1-minute metrics, and then soon auto-scale going from 5 minutes can go as small as 1 minute if you wanted to for averages for where things are. And likewise as well, the data retention is going from a couple of days up to 30 days for where it happens to be. And I respectfully have no time left, but I wanted to share with you the last 2 little bits of a slide here with regards to a preview for what's coming. The first thing that's been asked for is the ability to have images that are no longer just the images themselves. They want to have images with attached data drives as well. So that's also going to be coming soon in a preview for being able to do it. You no longer have to pre-create the storage accounts to be able to do this and do manual scripting to automate the loading of this kind of stuff. It's going to be good for big data, for Hadoop-type workloads, stateful workloads as well, and possibly legacy lift and shifts. On the roadmap as well, much better portal integration and also much larger scale sets. The maximum you can make right now today is 100 scale set units, and that's it. You will be able to go up to larger. Currently in production, in pre-release, we have the ability to show you, as I end off this section, the fact that we now have the ability to go even larger than that. So for the second time or third time only in the public, if I go off and take a look at this guy, they actually had to rewrite the tool to make it so they can handle 300. This is a 300 node scale set. They're all currently turned off. I'll let that start up the different VMs as I'm winding this up and basically wrapping up this one individual section here with the fact that there will be the ability to sign up and get onto a preview to get access to these. Right now it's a limited preview. but you are able to go off and to build your scale sets much, much larger. 300 is as large as we're doing right now. When it gets closer to GA, we're looking at a much higher level for where that is. And eventually you'll see these guys start to fire up across the board. All the same things apply. All the automation's there, all the updates are there, all the revisions are there, all the scale options are there, all the rules are there as well, but now you're less constrained for what it is. While that lights up, I'll flip back over to the last slide, which simply has some additional resources. These slides are available for you to download. The additional resources list off the different quick start templates you can use to get started with some of these things, to try them out yourself. Don't forget to ask for a potential capacity increase inside of your regions. And most importantly, I know you're interested in this, if you want to get a hold and take a look at that VMSS dashboard, that Python code of this that you're looking at right now, it's a open source project that Guy Bowerman's created that you're able to go off. A little bit of finagling to make it work, but basically it requires a service principal that can go off and manipulate your account. Once you've got that set up correctly, you're able to go off and to view these different types of things and make these API calls without having to worry about the programmatic side of things. So there must be something going on in South Central US because these guys should have started up by now. The Christmas tree should be starting to light up. So with that, here are the resources you can take a look at for some stuff. And as well, there's the URL for being able to get access to the VMSS editor. It's completely unsupported, but it is there. You can clone it down from GitHub and then get more updates as it comes. Guy Bowerman is the guy that created that one there. But with that, I am now, doesn't tell me how many over I am by, probably over by about 4 or 5 minutes. I appreciate you sticking around for this lovely discussion around scale sets. And I would be more than happy to answer any questions you have with a beer in my hand at the celebration party tonight if you want to go off and talk about scale sets. I see 2 thumbs up from the guy in the back there. I appreciate that. So if you have not already, make sure that you go out, fill out your eval. You still have a chance to earn a Surface Pro 4 and some new Xbox One S's. And likewise, I would be thrilled to have some kind of comments about how to make this scale set demonstration and content better and how to do the sessions better. Thank you very much for coming out and sticking around so long. To the party.